look at some...
Hold on a second, I apologize, I just had to hit record.
Okay.
Okay, you can go now.
Today we're going to look at some transformations of functions, and I have two here that I want to sketch the graph of. The first one is x minus 3 in parentheses squared minus 5. Now what I want to do first is make a little sketch or a little dotted line of the parent function. So the PF, the parent function in this case, is f of x equals, take a look at the highest exponent, x to the second power. The quadratic, the square function, that is one of our family of functions in the library that we have of all these functions. X squared is really one of the most important one. Now let's also write the transformations down. We have x minus 3 in the parentheses. That means we're going 3 units to the right. So the right 3 and minus 5 at the end means down 5 units from the parent function. So the parent function is x squared, and I'm just, like I said, I'm going to make a faint, well, not so faint, but here you go. Dashed little line, that is my parent function, f of x equals x squared. So based on this parent function, I now do all my transformation, and again, it is a sketch. If I want to do an exact graph, I would make a t-table. And my point of reference, especially for x squared, for the square function, is my vertex, my lowest point, which the parent function goes through 0, 0. Now what I need to do is I need to go from my point of reference, the vertex, from 0, 0, I need to go 3 units to the right, 1, 2, 3 units to the right, and then I don't stop here because at the same time I'm going down 5 units, 1, 2, 3, 4, 5. And my new point of reference ends up right down here, which would be 3 comma negative 5. That is my new vertex. And now I'm just sketching, like I said, this will just be a sketch. I draw the general shape of a parabola, and here we go. That is the transformation of the parent function. Beautiful parabola. There it is. Let's take a look at this one here on the right-hand side. Square root function, square root of x plus 1 minus 3. Now the parent function in this case is y equals the square root of x. Parent functions, they never have any numbers. They just have the original function, square root of x. The transformations here, we have x plus 1. That means we have to move to the left 1 unit, so left 1 from the original parent function, and we're also going down 3 units. Okay, again, I'm making a sketch of my parent function, which more or less looks like that. Here you go. That is the square root of x. Now my transformation, I'm going from my point of reference, in this case again 0, 0, I'm going to the left 1 unit, and at the same time, I need to have some scale here, increments, and at the same time I'm going down 3 units, and my new point of reference ends up right down here at negative 1 comma negative 3. And then I just, like I said, I make a sketch, and well, I actually, here you go. That would be the transformation. Now let's take a look at this transformed function. What is the domain? So you can find the domain. Again, the domain are your x values. This graph now starts at negative 1, as you can see, and goes all the way to infinity. And the range is, our lowest y value is negative 3, and we need a bracket because negative 3 is included. and it goes to the space station, which is positive infinity. While we're at it, let's look at the parabola as well. What is the domain and range of this purple transformed parabola? The domain of any parabola, and don't you ever forget it, is what? Negative infinity to infinity. Domain of any parabola. The range here, we have to look at our lowest y value. The lowest y value is at -5. And this one as well, as you can see, goes up to the space station, which is infinity. Domain and range for transformed functions.